Thank you, Ibo, and good evening. Thank you very much, Professor Sumedha, for the invitation and to the SLAAS as well. Topic expressed well, interesting. Just to think, 2 years before today, on May 25th, that was the day that ship went down. Ship had the starting the fire on the 20th, but 25th the day that the explosion and the spillages and all the sort of things started to happen. So it's interesting to talk about an event which we believe has to be addressed by multiple parties in many different disciplines coming together if we are to make something of an advance. In a sense, you will find always when something serious happens, a disaster of sort, accident, there's always a chance, an opportunity in that, even though that event is not something we should like. But if we do not understand it and learn from it and ensure that we take steps in mitigating for future events like that, the society will not going to advance. So again, coming to think about it, it's like Express Pearl was not the first ship. It was not the second ship either, but it came in the heels of MT New Diamond. So it's interesting to think what we are doing and what we have to do and ensure that Arthur C. Clarke may say that there's sometimes things happen in three times, so in triplicate. So we have two, and another one, if we do not make any advance, if we do not understand, we may face an issue. So it's just that I want to touch how do you bring, because SLAAS has this interest of looking at interdisciplinary and transdisciplinary. So I was just thinking, okay, should I considering that is the very first one, because we are more used to thinking the subjects that we are conversant with, and we have a kind of like a domain knowledge and understanding of the processes that are applicable, and we always think to outside, okay, that's not mine. But when we see a problem, do we come together rally around and share what each one can put on the table? And then either we move it to a satisfactory conclusion by this sharing and then learn from each other as well. And we know then the problem is really getting serious attention and we find a solution. Or again, we come together, we share what we have, but again, in terms of us, we also transform ourselves beyond our normal boundaries. And probably that's probably what is really valuable or must be useful to have. So in that sense, that's what we are talking about, interdisciplinary and transdisciplinary. So you have it essentially in the sense that it's coming together of various disciplines, and it is not just science, can be in many other areas, and situations like Express Pearl really indicates, because whatever the science says, sometimes it seems to law dictates, and sometimes international scenarios dictate, and then we as the victim, in a sense, the country was a victim of this event, right? And we directly suffered in the Western province, in some parts, directly suffered, and may have already suffered in some way, which we think as irreversible, but we may not yet know that. So, if you want to make this, okay, we have a problem, we are looking at a solution, and it should not happen again. How do we learn? Coming together, sharing our best practice understandings, and then moving forward to a solution. So transcending boundaries or maintaining their own individual identities, disciplinary identities. So that may be the difference between the interdisciplinary and transdisciplinary. So I won't go into that because the interesting point what I want to thank here is this table is courtesy Bard, because I just thought I'll try ChatGPT or Bard and see what gives me this, what is transdisciplinary and what interdisciplinary. Should I have a lot of databases to cover and come up with the thing? Interesting, the Bard gave me a table. So I thought I'll opt for the Bard rather than the ChatGPT. Your ChatGPT was a little specific, saying, look, you need to go beyond your community, your peers, and more reach out to the actors in the society. And unless you do that, you're not in transdisciplinary. So whatever it is, that may be another point to discuss, because we know we cannot solve our problem just by sticking to our peers and where we understand each other well, because we have people who take decisions without any of these consultations, and all of us may be affected by sometimes those decisions. Evidence-based decision making, it's not happening. So thank you, Bard, for this. It just just for an explanation. So let's get on. Yes, we do have. I mean, we need transdisciplinary or this moving across our boundaries, transcending across, and really uplifting, because we have complex problems. And from an innovation point, we like to call, we have wicked problems. And I suppose in Sri Lanka, mostly it's the wicked problems, right? If you take the complex problems, you still have a pathway. You can find out they are complex, yes, because multiple variables, but you still see, if you plan it well, you probably can, you have an idea that you can find a solution and way of addressing it, bringing parties together. But the scenario with wicked problems is that that kind of confuses, or it's like, okay, now we think we have been talking in Sri Lanka for 75 years, we have been talking about why are not we reducing post-harvest losses? Why do we endure 50% food losses? And while that is happening, why do you endure loans and so on and so on? And then on top of it, today we have got the worst 10 countries in the world in Sri Lanka is nutrition for childhood nutrition below 5 is one of Sri Lanka. At one point in 2019, we were sandwiched between Somalia and Eritrea. So that's the situation Sri Lanka is, right? So to me, that's a wicked problem, because if you look at it in another way, it seems very simple. You produce food, you need to understand preservation, you need to understand supply, and then understand prices so it reaches people. And then it seems quite, in fact, not that complex. I mean, not complex even. Yet, we probably now have to put food security, complex problem. And why in Sri Lanka this situation is a more of a wicked problem. Anyway, so it's interesting that we need to bring into the table a lot of ideas. And of course, with that attitude and the conviction that we must solve, we must move ahead and do. So it's important that we go beyond words and exchanges and somehow other find solutions also and make an advance. Otherwise, the problems consume us. So interestingly, Express Pearl. Okay, Little Theatre, it seems to be in Vancouver in a film festival. Express Pearl is making us a kind of like a presentation, but seems to be in Sri Lanka in place. But it's about how they have looked at the artist or the theatre people have come up with this, okay, the Express Pearl, the toxic ship, the place is going to be a problem to live. We must migrate, right? It's about talking, okay, now taking this as the situation about people moving away from a certain location because the place becomes toxic, it's not livable. And then you find your solution in another different place. Seems to be the Express Pearl seems to have given an idea for a social, I mean, like it's a social aspect that they are bringing in, but putting at the end, the center, a situation that is making the life a fairly problematic one because of this. And let's move away. So it seems to be this, this has made a mark of a sort in the people's mindset. Can we relate this scenario to a situation of this nature, right? Asylum seeking and migration and moving away. Interesting. Anyway, it's playing out now in Colombo. Right, so this is the ship and Express Pearl. Social, legal, environmental, all sciences including we can look at from remote surveys and things like that. A lot to learn, a lot to contribute to in finding the solution, right? And do we have problems happening or systems that are undergoing changes here that we are still unaware of? We know in the environmental world these things have happened before, and solutions or results come later, which we then track it down to about 10, 15 years behind and then say, okay, that was the causative point for this issue that is surfacing now. And we can go from the Minamata disease to climate change, coming up with a chemical, the ozone hole, and all sorts of things. We know that. And even sometimes we give the Nobel Prizes for the discovery or the introduction of that chemical for a health issue. Later on life, we international conventions, we ban them, right? So DDT comes to this mind. So it's interesting, right? Things we do, and then how do we, now here, of course, is not planned in a sense that it's a disaster, it's an accident that was thrust upon us, yet it unleashed so many areas activities in so many areas, and that's what we may not know. And for that, we need to bring in people together. So this is the unraveling the disaster and the need for people to come in and maybe to share and give your ideas, because otherwise we may be not addressing it. So this is a humble attempt to of a group of us when it was initiated by MIPA to study and tell us, come up with an answer to an environmental damage costing, so that we can go and present this as a claim for damages done to the country and to extract something out, and then to ensure that rehabilitation and regenerating, perhaps to put those funds into recovery process. So that is the objective of this exercise, that what we were engaged with. So I'm presenting a bit of those things, but hopefully you will see the complexity and then the mistakes also that we can make, and the more so the need to connect. And probably we lack in Sri Lanka this much of connectivity among professionals to see that, okay, here it's an issue that I can give something from what I know, and maybe that input is very important and that's not coming. Perhaps that's something we also should learn in that contribution part, working together. So it's all started on May 20th, 2021. And as we know, we always tell that our seas are quite busy. So if you take live maritime traffic, just captured it a couple of days back in preparation, right? You see, we are in a very critical point, and of course we say location, 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 and it's a very advantageous position for the country, and we should benefit from it. Yes, certainly. And we are in the trade point, so crossing from east to west and so on. So 300 plus ships moving around, and big tankers, chemical carriers, and so on. So on one side is an economic opportunity. On the other side, we also have, if something goes wrong, how it's going to happen. So that's the issue. So are we capable of, while realizing the benefit, we also should be able to be resilient again. If anything goes wrong, we should be able to handle it up front and before the danger comes. And this is the situation with Express Pearl, right? Which is, of course, not a mega ship. It's a very simple ship, small ship, but a brand new ship as well. Was going from the Straits, from the Malaysian side to the Middle East, and it's going around in that particular route that they are taking. So the point is, okay, if we are to look at the economic benefits from shipping and all these things that are moving around, and remember, on the other hand, shipping is the predominant pathway for almost all the chemicals that we are using for the industry, which of course gives us the quality of life. We don't do a lot of air freight on these things. It's always transport is ships. So all the chemicals that we are talking about is moved through this. And in this route, so that means Sri Lanka, down south, we are witnessing the passage of all these stuff of these chemicals going back and forth. Plus, of course, we know the energy stuff, which is the oils and gas and all that as well. So it's a very, very crowded corridor. And so the potential is high. When you look at the risk, of course, where there's traffic, there's potential for accident, right? So it's little common sense. The scenario is, okay, what is our state of readiness? And again, that is something that we should learn. So something, again, as I said, we are not this is not just the second ship either. So we have seen that a lot of ships had accidents closer to Sri Lanka and very close to the beaches. So when you look at, so it's the more recent ones, but some of them have been actually quite high now. I don't know how many of you remember in the Grand Bar in Trincomalee, sulfuric acid, 6,500 metric tons, right? So these things happen. And then on the one that's also covered MV Cordiality, about 30 kilometers north of Trincomalee, that's about also 700 metric tons of HFO, the bunker oil, right? And so that is less, that is much more than what New Diamond spell, right? So I'm just comparing. If you take a single chemical, it's quite a sizable quantity. So these quantities in tons, even if that is vegetable oil, do make an environmental impact. right? Because of the sheer volumes and the ability. So it's not a case of always considering, okay, this is considered a toxic chemical, this is considered a benign, but in terms of the biological environment, in that environment, in these types of loads when you emit, they do have the potential to cause serious disturbance. That has to be understood. But what I'm just stressing again is that all these events went through without an environmental assessment. Technically, there was no damage assessment, and Sri Lanka didn't follow that. So these two, with the MEPA initiative, for New Diamond and Express Pearl, it was done. And so we came into the New Diamond and Express Pearl. It so happens that 1 week after the presentation of the environmental claim, the report, suddenly the Express Pearl came. So it was like just team the moved on to the Express Pearl and worked. But I just want to see is this, okay, how this transdisciplinary, right, bringing multiple ideas into the play has to happen here. The first, all events in other countries, when you see, they made a contribution either at national level or at international level. So it's important to understand, right? And it's also interesting from an environmental point that it is one of the first, if you take in an international convention that was predominantly targeted for environmental support, damage and consideration and support happens in the maritime sector, oil pol, right? In that oil pol convention basically just came up to look at environmental damage is likely to happen, and there must be a mechanism, and that convention came for that. So the convention came with an environmental mindset, reasoning at the very front, and it happens for the maritime environment first. So when you take Titanic, for instance, and of course there was another one close a year later, but this is the most famous, as we know, SLAAS came, safety of life at sea, right? Making maritime transport, the shipping, the people, movements, and so on, how to assist ships, and what sort of signals to be done, and all that came up with this convention. Of course, the convention also goes up in, right? So one major event, 1,500 people dead, and then you have this kind of an international agreement, countries coming together and setting up, countries have to join, right? And you can imagine that so much of thinking has to go into this. How do we do this? So, so again, when you see all these events, so that's what I'm stressing, that for Sri Lanka, with these events, we must also make some effort, definitely, to ensure that Sri Lanka get positioned better, right? That we have become much more confident and resilient in terms of addressing an issue. And it's also a strength because you build your strengths based on the way that you carry on your task. Are we to retract or regress and say, look, these are very difficult, we are not going to do in this? Is that the attitude? Or are we going to take up the challenge? We will be becoming stronger and stronger because this is an area of importance to us. Let's do something about becoming very positive in managing. So Torrey Canyon, for instance, in 1967, it's affected both French and the British mainly coast, but it was a sinking. And then interestingly, the British even bombed this ship. Even they put missiles, not just 1 or 2 bombs, 162, right? And just to contain the oil and really to burn it away so that it was not spilled. So you can imagine they were looking at more the shores, the coastal area, not basically the atmospheric part, right? It's not the air part. So you really want to get it, and then you just going to study it because this damage done to the aquatic environment is considered to be much, much, much more damaging. So there was principle, you try to burn it away, and you still have that principle. And as you saw in Deepwater Horizon, you have this oil, then you, instead of trying to get it, you try to burn the oil as well. So that they did in Deepwater. So again, things like that, civil liability on oil pollution, CLC, and the limited liability for the ship owners also came in after Torrey Canyon, because the British went and seized ships on Singapore, and French tried to do that as well because they want to get money out of the ship company for the damage done to the country, to the environment. So it was a damage recovery exercise. But of course, then you realize while looking at your liabilities, they also set scenarios that limited liability concept, that the whole business world should not collapse because you may just go into liquidation, or if you go, so the different concepts also came in, and so it's that balancing. right? So you can see that we have to think, okay, while we may be looking at pure the environmental side or the technical side of it, then Dhammadi has to look at the entrepreneurial side, the business side, the investment sides, and all that as well, because you may just go on one direction and you may affect another one completely. And it's say if you feel that you are liable for everything, then people may decide, no, we are going to invest in this area. So you need to balance that. Then, of course, you have the insurance, reinsurance, and triple layer reinsurance in the maritime sector. So all these things are now have come in. So events, basically reactive, you add on to these developments to the system. MB Prestige, as sometimes some of these developments are very much policy, rule, law, and etc. On the other side, they do certain technical changes as well, right? So when the Prestige came and finally capped by when the Erika failed, phasing out of like single hull tankers, oil, because there's a massive release and all the pollution and the problems are faced, and it's very, very difficult to take this away. And they said, okay, now what if we have double hull tankers and remove all the single hull tankers away? And initially the idea came from this, and subsequently with Erika, they cemented no more double hull, and so always has to be double hull. So when you're calling on tankers to come into the ports, they have to be the double hull. And because essentially, if you have a problem on the outer, the other one, internal one, keeps the containment for the oil and should not get a problem. So that's the technical development. And there are so many things like that, right? And even in the naval, the ship design and so on. So it's very interesting to read accident after accident. So again, with Express Pearl, again, something like that. Okay, how about this? What happened exactly? Because most of the time, what we hear, unfortunately, the discussions are all the time on the wicked part. I mean, like that's what the wicked part may be. It's the corruption, the money, and the so on. It's there, right? While that is, it's not pardonable. It's not should not happen. But there's a portion of it, the technical side, and what if the next time, and so on. That discussion you never hear that discussion. We don't seem to be looking at that. So it's probably that's why it's interesting taking this as an issue. How do we make an advance of it? Even though that we have had a problem, how do we learn from this problem not to? Because again, corruption is also because of a lack of procedures. Corruption gets fed because it becomes easy because there's no standard procedure. And we saw that with New Diamond, going to Express Pearl, lack of decision making on the procedures may be lacking that in Sri Lanka, really paved the way maybe for corruption as well, right? Otherwise, you should not get this allegation because if the procedure is there, because then you really see a violation. So if the violation is very clearly identified, then you cannot give this. Now here you seems to be circumventing a couple of things, and then this allegation issues comes forward. Okay. So interestingly, most of the time we have had this energy-related chemical issue, which is oil, right? And so if you take on RENA in New Zealand, interesting thing is it's also about chemicals mostly. And so what I'm bringing this is a kind of like the situational readiness sometimes in countries. With all this knowledge, now you have liability schemes, you have a way of fighting it out in courts. And when RENA hitting the reef and broke into two, what was really interesting was the New Zealanders were kind of ready on the coastal belt that while the ship was breaking, they knew exactly what the cargo, they knew exactly what's going to happen with the the ocean, this dynamics of it, wave and so on. They knew it's going to happen. They took immediately almost the state of the environmental data at this stage before this pollutants hits the shore. So it's almost like you know exactly what was the condition just before the situation breaks. It's quite interesting. Because now you find the situation, look, you ask, okay, right, now you have some data. What was the situation before, right? And you again ask questions, okay, now, yes, this was discharging this many tons, but your colony has been discharging so many tons, right? And where are all these things have gone? So what's the state of what's the situation before and after? So you always go with that kind of discussion. And so you have to have the state of readiness to do things. So that's why I put RENA in the sense of what the New Zealanders in that sense is current day situation, that you have to have this state of readiness. So the environmental damage assessment, that is probably what we're talking about in bringing multiple dimensions people in, because it's not a one way of, it's not a simple answer, right? And I will just highlight also maybe the more challenges. Also, it's quite interesting in one way. So you have the ship and all those releases cutting across multiple environmental segments, doing a damage, definitely. And then what we were looking at was coming out with a value, right? So it's monetizing, or it's coming up with a assessment in rupee terms or in dollar terms. How do you account for this damage? And this damage is not only the status, it's also about restoration, damage, and recovery, and so on. So it's about the future as well. So, so this was the challenge. And also, it's also important to say that different areas, how do you communicate during an event of a disaster or something happening? You cannot, you have an incident, you have the accident, and depending on the scale, it can be considered a disaster. But when the scenario is developing, you cannot immediately call it a disaster because you're not seeing the end of it. But you know how it's kind of like growing or changing. Anyway, so what I want to say is we made those mistakes as well. It's a capital mistake to theorize before one has data, right? Evidence-based, because you go and you may tell certain things which may be taken out of context, and maybe because you're saying that from a very different point, you are a person of authority, and those statements do matter, and they also communicate how the others may respond to the situation as well. So anyway, it's very important that we try to understand. And then communication, how do you do that? And to make it more scientific, if this needs scientific, that science has to be there, the right science. So it's important to understand when a situation is quite live and complex, it's not just how do we act as a team. So what I want to bring is two things, like we saw here, the outside telling Sri Lankan faces an unimaginable cost of cargo ship disaster, right? So it is obviously it's unimaginable cost is in terms of environmental cost, because you see this picture and it presents quite a gloomy picture. And then again, it also happens in a time when we see a lot of other scenarios are developing. Like I'm just putting this plastic is already in blood, breast milk, and placenta. Now it may be in our brains. What's coming out is plastics. So why I'm relating here is because this show is full of plastics, and the ship was full of plastics, and all things came out. And then here we have now science coming out in different ways, indicating to us there's a big problem looming, because plastic is finding its way into places where they have never been seen before. And here we had an incident that immediately transfers a huge amount of plastics to the microplastics. It started with microplastics to the nanoplastics potential. So we don't know the science at this stage as well. So there's in another way, we have also been presented with an opportunity to be probably been exposed to a situation really just 4 nautical miles just outside Colombo here, right? And this major outbreak of sort, right? A release of chemicals and plastics into an environment, so many complex reactions, and what may be happening. So there's a lot of people who can probably support in understanding what's going on. That's what I said. There may be scenarios that we know that things are happening, but we do not know. And it's time we put sometimes this understand our knowledge into practice. We know situations like, if I remember the case of dioxin, when the world first saw dioxin, it was a Sweso factory explosion, and only chickens died in that. 100,000 plus chickens. Not a person was, but there was this one medical doctor who kept blood taken from that in his home fridge for about multiple years. I remember it as like 6 years. Till an analytical chemistry pathway was identified for the dioxins, and I mean, like understanding the typical chemical that was to be in the first place, then to identification of dioxin. So it's very interesting. Now we call that international or rather EU convention as Sweso directives for managing chemical plants, right? So you can see you need that type of, the scenario is, okay, we have this developing situation from science. We had an actual disaster that is the world's #1 in terms of plastic loss, which is about 11,000 metric tons of various types of plastics, right? A sort of complex mixture in itself, which went into this environment, and it's now got dispersed some got burnt. Of course, there's again things came down. So putting two and two together, do we have our minds working? Because can we identify something that's going on and take some action? Or can we learn from this? So here we have a significant opportunity as well of trying to get to know a situation that may be developing in future. So of course, the team that we came in, we had multiple teams. We organized them, obviously thinking of interdisciplinary, because we know that at so much of complexity that we just can't do it in alone, and it's not an easy task. But of course, you can see from coming from the root cause side, first get to know what's in there, and then different types of environmental assessments from biodiversity, air impact, aquatic resources, health impact, socio-economic, restoration and sustainability, waste management, water and seashore impact assessment. So multiple teams coming together, of course, and then trying to address this situation. So the event, it's that place or the seashore and so on is a live lab of sort, right? And it's not just the science of it, the social aspects were there because fishery folks were losing jobs, or rather they were not able to go. And then we were not eating, consuming fish. So you had mind, and then you have communications of sort, acid rain may be coming and things like that. So all sorts of things you can see. So there are the other different elements also need to be addressed. So it's interesting. So, but our task was this damage assessment, which all fed into like the economic valuation group. So hope so some of the team so Professor Prashanti was coming up with this economic. So everybody has to feed or see this and then put this information for the for her to do the calculation, the economic group. So it's interesting, right? So this is also in a way learning, because we also identified with the New Diamond. New Diamond, actually, it was like a smaller team because there was like one single chemical released and the ship was far away. And it was just one chemical. But interesting, in this case, it was like as periodic table was released. Essentially, the periodic table was released. So that's, and then it's very interesting to think what additional chemistry or physics may be out there, right, or happen. And specifically looking at environmental sciences. So this is the nature of how people come together. Now, I'm not saying that all teams clicked well and gelled well and contributed. So that's again something that we need to understand, right? The success finally really matters on not just the teams internally, but also the external parties who worked with the teams and coming in for the solution. This is why we need of a problem like this, a complex problem or a wicked problem cannot be handled probably by a smaller team. Or it will not be. Just that you need the participation of many to understand this is a common problem for all of us because it's a societal problem, right? It's an economic problem. And how do we bring our expertise and understanding and our fears and issues to the table to find the answer, right? Now, that's, I suppose, how successes come. Because if you take the example, Have you been doing like this, or the whole is from that side? Yeah. Appears not so. Can somebody mention, come on the chat and say if it's audible? Can you hear me? Okay, thank you. Again, 100% destruction of all contents. That's something. So if you look at again MV Rena, you can see a different. But of course, this was an issue because there was fires and explosions as well. So so these were factors I'm just putting because when you look at how the past accidents and scenarios, you find that why am I saying this anomaly, right? Looking at historical accident records, then you find that the reasons that normally you may find this sort of a situation is not relevant to express pearl. In a sense, it should not have happened. Now that of course brings me to that point where the causative factor was known, the actions were not taken, and somehow other long list of errors culminated in a situation. Once you kind of like allow that to happen to and come to a situation, a local party cannot handle it, right? Because you have pushed it to such an extent that it's unfortunate. Anyway, so I'm just giving a reference on this, that studies for a long, I mean, you can find this European Marine Casualty Information Platform, something again to understand that the data that I showed, the accident that I showed about Sri Lanka, we just cannot access most of those accidents. We just do not have access to those accident data. So we do not have we do not have the sharing and then understanding it from it. So we move from one accident to another. Again, something that I'm pointing out, it's important to have these things being shared and then the lessons, and to ensure that, okay, next time around, this is not. So that's why I brought in the international convention. They also learn, right? So there was not only one accident and one convention that solved all the world problem. No, there were problems, right? Now our scenario, the difference is we lack this type of behavior. So we walk from a problem to a problem, and it's unfortunate. And act to an act, right? So we want to understand this aspect of so many things. Sometimes, unfortunately, even though the event seems to be so big, some small technicality, because we have not got that part of the part in the process, may have an issue, right? It's the way probably the human society works today. So that's what I mentioned. It's not just sciences. The legal parts have to come in. Now, some interesting legal scenarios are developing with respect to this Mauritius ship that Waikashu in the Japanese tank that had problems in Mauritius. So you can see that. And interesting, probably Sri Lanka, we are also seeing the legal, because you hear these situations of 2 or 3 lawyers comes together, they do not know what courts to put this at. And then you go to Singapore, then again you see, okay, no, I move from this court to this court. So that is just within one. Not multidisciplinary, no interdisciplinary, in one discipline, right? So it's interesting. So we need to understand. But we also need to understand how do we exchange information. Otherwise, we will be looking, we see that we probably are dealing in, because thinking science in a very science way or in a very academic way. And then, of course, this battle has to be done in a separate place. We may not understand that scenario as well. So if we ourselves get insulated from this reality, then our work is also not maybe that meaningful. So it's something to be conscious of. So we need this dialogue from the beginning. Again, why we bring people together.
So you see that multiple environmental segments were affected in this, and probably some for long term, right? So air seems to be the one that we least worry about, in the sense that we consider air as a very good dustbin, which we have been doing for a long time, right? But so the rest of it, we try to protect to a much greater degree. But of course, we know now we can't do that. We know more people die from air pollution directly in current days than from the other, right? So all air, water, land, bioestuaries, sediments, soil, all the environmental segments, you name it, were kind of affected by express pearl. And in some cases, to a greater distances as well. So our first thing was, you see these images, and those images were plenty on the early days. And just to keep in mind that sometimes these images do, I mean, like scientific inputs would also be very interesting. When you see an image, people can respond, right? And that's something also probably a culture that we need. Commenting and then seeing, it's not taking an image for this graphic value, but what's that image says. So that's probably, again, certain parties who can contribute and come in, right? So beaches, whatever. Something we said at the beginning, that we will study this from two different ways, or rather we'll understand this as the base. That is, we understand there's an acute phase and a chronic phase. And chronic phase can reach into multiple years. And acute was, we think, thought as like 3 months, right? And even in both phases, we will have visible as well as invisible. Things will not be visible. Things will very quickly disappear, even though the damage would be done, right? And we said we will use 4 types of approaches in this. And something interesting, because the courts will take not all of these in. That's a challenge. But we said, look, we have to understand this is the way we have to study this. We cannot do the other way. So we said visual evidence have to be, the anecdotal visual evidence has to be looked at. And then analytical evidence, and then model-based systems and research-based. For instance, for Sri Lanka, we cannot measure dioxin and furans. And none of the samples have been kept, so we don't have the samples. So the point is, but we said, if you have this chloride environment, see what has been used in, and then all the plastics, the rest of the chloride and stuff, PVC all in, likelihood of generation of dioxin and furans under temperature conditions. You look at the picture, you look at this scientific data, the research suggests you have to. So then you go into model and research-based assessments. You just cannot show that existed. You have to take it for granted from a science perspective. The knowledge is well known that this will generate this much of dioxins and furans, kind of thing, right? It may not be exact, but we need to work on the sensitivities and then come up with a value. So this was the framework we tried. So you can see this billowing of smoke and so on started around May 20. I mean, like the serious work started May 25th, and then went up to about June 2nd, when the ship sank, right? So it's about 12 days of fire. So you can see we also had to study the understanding of what was they transporting, right? And it's found to be quite interesting cargo. Of course, container cargo, everything goes through these ships, so they have to be. The lives, the economy depends on how the ship comes, when, and what it brings to you. So the cargo was quite interesting, and coming out with data. Part of the challenge, of course, was you do not get full communication, because aggrieved parties or the affected parties, they look at as, it's more antagonism. There is no such thing as partnerships. So you don't get data being shared like, okay, this is how the ship was, this is what has been loaded, and so on. That data are not forthcoming at all, right? So you need to work on it. And those are what normally comes out with international agreements as well. Under these conditions, you have your responsibility to share information. So we managed to get these details in about 3 different ways, and so coming out and putting them together. So it's interesting. You can see that the cargo, when the first cut of these data, we actually had personal effects and so on, personal cargo effects 310, and other stuff. We had these categories. So you can see plastics and polymers about 11,000, 12,000 metric tons, and then chemicals coming up to about 8,000 metric tons. The metals, various smelter metals, waste as well, coming up to about 3,000 metric tons. Food items coming up to about 3,000 metric tons. And then the personal effects and other stuff, rubber, furniture, all sorts of stuff, pharmaceutical, I mean, like some of that packing onto 5,300. So that's the breakdown that we had to come up with a summary to identify the main material pillars that we are seeing. And of course, later on, when we went through some of the cargo, like personal effects, it was interesting to think, okay, suddenly we thought, look, this is, you cannot just say personnel, because they are like electronics and electrical equipment. Now, when you talk about electrical and electronic equipment, all of them are, of course, they were working stuff. Now they become not EEE, they become WEEE, waste electrical and electronic equipment. Suddenly, another 300 metric tons of e-waste now as pillar, because that carries half of the periodic table in a, I mean, like when you say a mobile phone, you will find in a smartphone about 47 items of the periodic table in that smartphone, right? From rare earths to all sorts of stuff. So it's interesting. Now here you have 300 metric tons of that also being deposited onto the ocean. And if they go up in flames, they will also come down, right? Because they don't disappear. So it's interesting. So we finally came up with this type of a breakdown for polymers, chemicals, metals, food and other, and e-waste, etc. And of course, still some of the unknowns are there. Some of the chemicals, they are not declared as environmentally hazardous chemicals. Some are declared as inorganic chemicals, which we do not get any data on. And but they are significant amount of tonnages as well. So it's really, but this is the best we could do. And of course, on top of it, we at the ship itself becomes a polluter. I mean, like significant one. Firefighting chemicals, right? And we do firefight with sometimes not the best of the firefighting chemicals, right? And then the HFO, that's the heavy fuel oil, and then associated diesel and the lube oil and the waste stuff that's in the ship on board. And they also get into the system. So this is the one. This is why we say, this is quite interesting, almost all the periodic table are there. One thing, the ship was very clear, and the declaration that they didn't have explosives on board, and they didn't have radioactive materials on board. So that's the classification they do when you approach harbor, and that's that was clear from the manifest and so on. That part, they didn't carry those two items. Again, the next one was finding the positions, because the root cause was finding the positions, right? And it's interesting, if you have some resources comes together for interdisciplinary and so on, it would be interesting to see the logistics groups coming and saying, look, when we load a ship, we have this software, you come up with a manifest, you get your ship design, you can say this is the way the storage plan has to be. You can immediately today generate the storage plan from the software. And they do practice it in our jetties as well. But that kind of connectivity was missing. So we were not able to do it. So we were using the submitted the data sets of where they were there. And it was interesting, unfortunately, where the nitric acid container was present and the hatch cover, when the nitric acid leaked, hatch cover was consumed, and then the nitric acid went into the cargo hold. And the point was, this was going on for like 8 days, right? Even though the comment was it's 1 liter or 1.25 liters per hour. And that was a visual assessment, not a measured one, right, from the ship. So it's interesting. So we looked at examples again. We saw that there's been a ship, nitric acid carrier in Rotterdam and in the Rhine River, which has been about 25,000 metric tons of nitric acid, which actually had a leak of nitric acid from a tap and a valve, and only for 8 hours long, and it reacted, the nitric acid reacted with furniture, and then the whole thing went on. The ship got totally destroyed. So it's interesting when you see. So then if you know from past accidents and the scenarios, then this is what we say. Look, you should have had access to this knowledge, and you should have had the best practices, right? And somehow or other, that's the way this situation. So the release, so that's what I said, the causative event, the way we see it, the leakage of nitric acid from the container was there, it was known and communicated, but not right actions were taken. So the next part were like these, the analytical studies, and you had the teams, you had the specialist groups, autopsy, sampling. Again, something to be known, how do we work in these groups? Because it matters that you take your samples, right? Remember I told you about the Mirena, right? Getting your samples before, ensuring your datum. When things start changing, you again work on it, right? And there has to be these protocols. So need for real good to working together for this. And that's why we also raise for citizen science contributions. We put this up very early that anybody who is working in these areas, reach into any scientist, any even NGOs, please, once you collect the data, do submit the data. If you have samples like that, please connect it to the MIPA, right? The idea was we need collections. And in fact, like Professor Ruchira used to say that we would have to have even a samples to a museum type thing where you can, like for later on, the samples are there for as evidence or even for that, but also for learning, right? Because this is throwing out some very interesting stuff as well. So first part was air quality. This is because most of the time, just one more thing to stress, what we saw with this ship was that the cargo, because it was 100% destroyed, we do not find a ship accident before that was discharging this much of plastics. So this becomes number one in plastics, losses from a ship, right? And like 13 metric tons, 100 maximum was that type of thing. So this gone to about 11,000 metric tons. And then the amount of chemicals lost also we were not able to find. This is something, even if you still see about the discussion, the international press doesn't really acknowledge this to be that the most worst in the chemical discharge form as well. Even though the HNS convention is there, HNS convention is not being stratified and support, so it's hazardous and noxious substances international convention is still not active fully. Even though we now see the importance of chemicals, because chemicals become a cornerstone of the society, all of our stuff. Anyway, and on top of it, so we believe that this is the worst case in accident in terms of plastics and chemicals together. And on top of it, we had the fire for 10 days. So there was more of a reactive environment, a serious reacting environment in presence while this whole thing was happening. That also makes it a more complex thing. So you can see the ship, and the interesting point was the monsoon time. And again, there was a cyclone at few days. And again, it was on the 25th that it hit Colombo, right? So you had it coming into the country. So all these chemicals were going in. But what was interesting was the ship controls were only announcing it for not for the people, but announcing it for the rest of the other ships that may be moving around. So with something, again, the communication Sri Lanka needs to come up with, right? Remember I mentioned about this nitric acid accident in Amsterdam, and there was a communication to the people, there can be this gas cloud coming in your way, right? Because of the fire and so on. Now, that type of communication system, you can imagine, one is a science communication, but the response can be pretty bad as well if the society is not ready. Something to think about. But for Express Pearl, the communication was to avoid this plume by the other ships that are moving around Express Pearl. There was never a public communication, right? But the point was, the cloud was moving to the ground, like to the land, not parallel to the shore. Right, so we do have some unique chemical products, multiple reactions, fast explosions. So there's a lot of understanding. Now just imagine, so we have put up this 2D matrix to look at the chemical reactions and the potential, because A can react with anything, right? And I showed you with the lithium, probably the first time an entire container of these electric car batteries was lost to sea. You do not get another record of it, sort of, right? But not many communications comes. We do not have access to that. But certainly on a reactive point, this was sitting next to, and so there was definitely the fire hitting that container. Okay, so and then subsequently, that's an explosive issue. So you demonstrate things like the invisibility by demonstrating how the fish can disappear once you have caustic. We do not think that so much of acid hit, but definitely there was so much of caustic. So basically, sometimes you ask, okay, where is this killed fish? On shore. the point is most of the time that some of these scenarios, the fish would simply disappear, right? In a very few minutes, in the very closer. So this was Professor Metlika demonstrating it to the Attorney General of SOT. So kind of trying to saying, what do you mean by this invisible evidence? Don't ask for evidence, some of that, it's not there, right? But you have to understand from the point of the temperature rise and the nature of the chemical and the reaction, that some of these things are not going to be there for you to capture evidence. You need to understand this can cause this much damage. So what you need is some prior data on the biological diversity and the density and the amount. And that you then identify that is likely to be lost in this interaction. So parts are modeled, and this is scenarios like from Professor Pacharachis from the very early days, demonstrating that the plastic stuff will move into so much of distance away. And definitely about 300 plus coastal belt was fairly covered with the plastics, small amount, in some areas in large amounts. So, and the thermal imaging, modeling, air modeling by NBRO, and so many, I mean, all these things were brought into the study, right? Of course, we can do more, but something that is lacking is the computing strength. Not the knowledge part, but the machines, the hardware part, accessibility, right? So you still have nitrogen modeling happening in UK in this project, in this exercise. Some more interesting, right? Said you need to do this type of setups near the ship and so on to study the things that may be leaching out from the ship because as the wreck came in and so on. And so again, like the NARA research vessel Samudrika trying to do these projects, research activities on sea near the vessel, near the shipwreck. So you can see so many areas are needed. It's quite interesting for study wise as well, because there are a lot of unknowns. And even if you are to tell the story, the narrative right, you need a lot of data to come in. And in almost all these environmental segments. So I'm not talking about corals, seagrasses, the mangroves, none of this is in here. But you can imagine in all these 6 environmental segments, the interactions were there. What were the interactions? Were they, how much there were negative interactions and how much they're going to be acute and long lasting? So there's a lot to do, and then to calculate, right? I just give one problem just to highlight because of the nature of the time. Interesting problem, how clean is clean? So this is the Sarakwa beach. So when you approach that beach, because this was the one that was closest to the wreck, so it was like the wreck is about, that's a 4.2 nautical miles, right? And so there's a lot of, the earlier pictures of this black and white seashore was from Sarakwa as well. So you can now find people trying to clean. And then you have this pollution, plastic pollution index. How much nurdles are there on a square meter, and then on a depth, and there's a lot of studies have been done. The question is, are we to pick the last needle, right? That I think is a very interesting multidisciplinary issue. Or rather, somebody can be very physical and say, look, I want to get the last nurdle out, because then I'm putting that beach back into the beach. But then what's going to happen to that ecosystem that's there, the biological ecosystem that one is having? And then from a coastal point, Sarakwa is, I think, disappearing beach because it's a monsoonal setting, and then it's a more dynamic beach, right? Which comes from coast conservation, but then there's another ecosystem that's associated. So that's an interesting point. How can we say where clean is clean? So you find a lot of discussions we had in Sri Lanka, but unfortunately all about even showing pictures like, okay, if we use the machine, you will be in real trouble. Wrong interpretations maybe, but anyway, are we to look at mechanical systems? Are we to look at manual system? Then on top of it, when the manual systems are done, what's the exposure to the chemicals that they are going to face? Because they will have, and then maybe even the extra heat that they are going to get working in the sun for a long time period. So, multiple issues. You are now trying to clean the sand out of nurdles, right? So that's the objective. So you have to have this question, right? So one of the big disadvantages in this one we have is one of the real serious issues is that even though this plastic pollution index has been calculated, it is with nurdles. We have a lot of burnt plastics, right? From resins and stuff that have come in. See, and you can see a huge complex one, and they are very much fragile, and they break into small pieces, and so on. So that is not counted. Most of the time, the story is about the nurdles, right? And plastic, one of the things is they act as pollution sponges. So as it moves on, it collects, it cleans up the environment in a way, but it captures. And then how do you do another biological transfer to another biological species when that plastic is taken or ingested? So interesting. So you can see one of the early days, you find the stuff. So a lot of contamination on the plastic surface. This was a very early day experiment that was done. And so this is a complex plastic. And again, I think this, of course, we said this is the very first time for this quantity. This type of study probably the very first time because you do not have got so much of complexity into this waste in other spills. So you can see, but these are Mythica's publication. So you can see some of these, the ship had sulfur, nurdles have like yellowish, right? So there's a lot of interesting stuff that goes on. And when they come a year later, right, they have gone down in size. So what has happened? Microplastics have been drawn into the nanoplastics. So a billion issue is now a trillion issue, an impact. So that can go anywhere. Remember the first picture that I showed with in blood, the placenta, and so on, right? So we have also the other scenario is how clean is clean. You find for multiple number of meters, you have these nurdles going down. So this is a publication from them, right? And so are we to take all that sand and then subject them to the cleaning and then replace it? Is that the solution? Still this question waits, right? So you are using machinery, backhoes and so on to take the scrape, bring it clean, and on that process, you also have other additional hazardous waste generated. Sorry. On those barrels, you can see because the wash liquids, they're pretty. Those collections they have to be handled now separately, right? Because they have concentrated waste, and so it's interesting. So sometimes when you have little bit spread, it's different toxicity. You collect all that together, you now have a load that you need to manage differently. The hazard doesn't change, but the point is the risk changes, right? So it's interesting question that I take it as you need to put in thinking to address this issue. Where do we draw the line, right? And it's an interesting problem that still awaits. And of course, in the whole of this discussion, most of the time, the ecosystem, the biological ecosystem was never, I mean, I know it was highlighted, but it doesn't get addressed because you're looking at how to clean the beach. And that's the visual part for the human point. We, for aesthetic and all that reasons, we are looking at cleaning the beach, right? And also interesting questions came when the scenarios like, okay, Sri Lanka cannot have this. So this is an interesting comment that came from in one of the discussions, right? But 1 year later, we found this fluorescence stuff on the global face, and Sarakua had this green stuff coming up. So the point, remember, we had also about 3,000 metric tons of food waste and stuff, and nitrogen. There's huge amount of urea as well on board, right? And all went in. So that is leading to the eutrophication and then this support. I don't think you can hear, but yeah, this is about saying, no, Sri Lanka never had these algal scenarios, right? These blooms and stuff. It's unlikely. The river mouths are spewing out this much of nitrogen, but we are never observed. But it was interesting that in one of the surveys, right, very quickly, one bucket into the water, get the sample, go to the microscope, you find this, this what you call the diflagellates, right? Dinoflagellates, which are the red tide, and then you have some of them have toxicities, and you swim, and then you will have the issues that can come in. So you can see, but for that type of results to come, we need multiple parties coming in. Now I'm just giving this example, and these are like long term, because as I said, in the very first instance, this is not possible, but you were seeing it. Year later, we were finding, but you cannot still track it to the ship, or maybe unless you have the connectivity and studies available to see the nutrient enrichment and this growth taking place. But this was very much on the day when this statement was made. This was identified almost at the similar time. So we were kind of saying, no, this is possible. So it's interesting how much people coming together can contribute to an issue. Again, our main flagship issue was the turtles, in the sense because they were the ones who died most. And then, of course, you know, they are endangered species. Sri Lanka supports 5 out of 7. And then we had this massive amount of deaths. And again, the research base was, okay, you find some of them stranded on the beaches, but that means for one turtle they're stranded on the beach means 5 of them may have got washed away, right? That comes from a research study from another scientist in another country, which is, of course, the Mexico Bay, right? So you bring that type of scenarios in, and then you factor in, okay, this. But when you see the kind of like the geographical situation, or rather the positioning, you will find Sri Lanka may have lost much more in deaths than the Mexico Bay scenario, because the way the waves are moving and so on. Anyway, so you can see this, and again, still argue how you are to take the turtle was affected by this. So then you go into statistical and the studies of that, because at one point we were thinking, okay, now probably a turtle has to get up and show the ship and say, look, this ship killed me, right? It's to that extent sometimes a question. But that's the way sometimes the questions are asked. And we are from science are supposed to have that answer. It looks almost quite difficult, right? So you can understand, maybe you have to go into much more serious isotope techniques and then see and then identify. Maybe the answers are there still, but you have to see how do you work together for this. Anyway, so this is interesting. And again, like the study of carapaces, right? These are not the normal way the turtles die, which have been seen. And then you see very different carapace situations, and maybe for different chemical reactions, the heat and so on had led to this. Again, a set of atlas of turtle deaths over the years. If the data are available and we have a very good data collection in our system, it's much easier to manage these situations. So it's important for us to understand we need to have this data sharing, data collection, archival habit in support of science, right? So each one others can support with this and have these different interpretations. So it's important. So significant chronic effects that will highlight, which needs, again, really serious interdisciplinary or even elevating yourself is on this, right? So you can say a very recent publication which came up from the Express Pearl, and then whether the Indian fish is bad or now the Sri Lankan fish in terms of microplastics. There's researchers from India, they're now finding fish on this side, this on the Gulf of Mannar, that Sri Lankan side fish at the moment that they have caught has more plastics in their gut and so on, gut contents, than the Indian side. And actually, the last line, they declare that we really don't have a problem because the wave dynamics and the oceanography and so on stuff. So it's interesting to think, but again, it needs more studies, right? And what's going to happen with salt, right? Microplastics in salt, nanoplastics in any place. So there's huge amount of unanswered questions still are surfacing. So most probably when Professor Prashant has calculated this cost, right? This can be a very serious, but it's also maybe a world's first time this calculation is done. But it needs more science going in. So it's interesting. I will kind of conclude. Nerdles, 1 container billion problems is what somebody initially said. But the point is, it looks like it's getting extended from billion to trillion because of the way it's going to be for many years. And in this particular conditions, the plastics will break micro to nano very fast, and that will get into multiple biosystems and magnification and so on. So it's something to be aware of, and then we need to have some resources to check. So again, a cry that we make is to have all this data coming from the system to be used by science to learn this thing. Maybe current decisions may be not that right, or maybe in future to understand. So to have this, using the tools that we have today, why don't we make use of these tools to have a much more of a sound database? You can, it's like the Titanic picture that I showed. It was a very recent computer rendering of the Titanic, which was kind of said that they have done this. So new tools, new opportunities in then probably understanding better. That means different parties coming together. Let me share what I can do with what you're having, and we have a different insight. And that's where the advances, that's what I suppose we are looking at, right? 2 different strengths coming in, and probably that with transdisciplinary, you actually elevate yourself also away from your normal boundaries to another level. And certainly this complexity needs that type of thinking. Otherwise, we may not have a problem. We have a problem. For example, when you see on chemical effects, data on maritime pollution effects of the most transported chemicals is limited because most of the time chemical accidents have been rare. And when we had the brand new ship with lots of chemicals on board, we had 100% loss. So we have a serious situation, but a lot of unknowns, because how the periodic table reacts with periodic table is an unknown question, right? So it's something that we have to think how, and in different energy states, maybe the reaction. So probably a lot of stuff that we can unearth from this, and we should learn from. So finally, it will go into this natural resource damage economic claims, which of course the economic team, Professor Prashant's team is grappling with. And it's also a challenge because sometimes people do not understand this issue of this natural accounting, resource accounting, and then maybe the direct cost. Again, that probably needs a different way of communicating. Recently, there was a very interesting calculation for Sri Lankan elephant, which about the value of like $11 million to a 20. I mean, when you look at it, let's say the sales value, maybe the financial $27,000, but in millions US dollars. But there was another line that underneath in Sri Lanka, the young elephants or the babies, basically 54% of them die with malnutrition. Just imagine another flagship mammal on land. We have a big issue, right? And that valuation should spur you for action. In a sense, look, this should not happen. I'm not only saying extract the value, right? But this is when you live through for a natural death, not with hakapatas at some point in the midway. So this seriously we need to think about and come together. And this exercise is interesting. So the maximum today for environmental deep water horizon, $20.8 billion. Interesting from environmental, but you know, there's this 6.4 that we have been looking at and considering, but we said it's work in progress. It's still not done because more work can be done as I exposed on the chemical side and the plastic side. The value is still open. And there's so much of science and understanding need to come in. Thank you.
Yeah, thank you so much, Professor IGT Alvis, for this nice presentation, which is informative. I think you needed probably more time, right? And tried to basically present within the allocated time. I think now the floor is open for a discussion and questioning. Shall we give the opportunity first to those who are joining via Zoom? Then he can directly answer, and then we can give the chance to those who are present here in the audience also. Those who are joining via Zoom, please post your questions or comments so that we can see your questions and comments.
Professor Ajit, thank you very much for that presentation. We learned a lot of things that we normally would not have come to. I have 3 questions. First of all, you harped on the point that people should be willing to share data on this. Would you like to share your presentation with us? Okay, thank you very much. Most people don't, that's why I asked. Okay, next one, maybe this might not be directly related to your area of study. In the aviation industry, when an aircraft is in disaster, they have the right to land anywhere they want. Why did India first reject and why did Sri Lanka reject taking it to harbor? And why don't the harbors have special arrangements to contain the damage even within the harbor or special arrangement close to land to mitigate the damage better?
The question of whether the ship was not allowed, ship was allowed in both Qatar as well as in India. Hamad and Hazira both allowed the ship to come in, but in the Hamad case, they said we don't have people to do take this container and so on. In Hazira also the scenario was that they kind of said we don't want to do it. But I think the situation again from the ship side, they were not too much saying this need to be done. They were not raising that emergency level side situation. That's my viewpoint here. I'm just expressing because the orders have been, okay, now go to the next port and try to get it done. And after Hazara, it was like Colombo. But approaching Colombo, again, our knowledge, Colombo was never told that as the ship approached that there is this problem on board. So if the ship said we need priority berthing and manage this container being taken out, probably it would have been arranged and the Colombo would have done it. Because what is interesting is probably not known to many, maybe there was another ship with the nitric acid in a container that was addressed by Colombo because it was on approach. They told we have a problem in this container. It was taken into the harbor. It was corrected and the ship went back. So Colombo has the ability, but Colombo was not told that when this ship approached, why they put anchor outside. They would have asked for priority berth and then taken it and done it. So this is when I said that captain's absolute responsibility of the ship, if that knowledge was there, that this leak is continuing and this is pretty bad. This is not giving that example of that the Dutch ship, right, of nitric acid carrier. It's a chemical carrier. This is a container ship. Of course, different emphasis by the captain. But he would have even looked at taking the containers away, plus 3 or more containers to the sea. Can have the right decision been taken. So that none of those decisions were taken by the ship side, and the advice from the main office was to move on to the next and try to get it addressed. But while approaching Colombo, they never told Colombo that we have this problem on board. Can we come and do a check? They never said it. They just sat outside Colombo, they anchored, and then the fire started and all that, then asked for rescue from Colombo. That's what I said, once you have escalated it to a certain situations, probably we are also not in a position to address it. Because the problem has gone out of hand, gone. At an early stage, if you had done it, you would have done it. Again, some of the ship safe things. Ships should have had water lancers that should have been from end to end meet, because this was an on-deck container, and they would have been practicing, trying out that to ensure that it was not getting into a... So I think on-board situations was pretty bad, the decisions taken. That's what I feel as negligence, but that's from our team of root cause and so on. All right. So Colombo is not at fault from our point. And Colombo did demonstrate that they can handle it if this was known 3 months later down the line.